Welcome to the Rebound, where we'll explore the issues facing supply chain managers as our industry gets back up and running in a post-COVID world. This podcast is hosted by Abe Eshkenazi, CEO of the Association for Supply Chain Management, and Bob Trebilcock, Editorial Director of Supply Chain Management Review. Remember that Abe and Bob welcome your comments. Now to today's episode. Well, welcome to today's episode of The Rebound, GE Appliances 3D Transformation. I'm Bob Trebilcock.
And I'm Abe Eshkenazi.
And joining us today is Alison Seward. Alison is the Executive Director of Manufacturing Quality for GE Appliances, a hire company, and one of the largest manufacturers of appliances in the U.S. Alison, welcome.
Thank you so much for having me on today. I'm really looking forward to this discussion, Bob and Abe.
Well, we're glad to have you. So let's talk about digital transformation. Now, it could be the hottest term in business today. I did a quick Google search and it returned 987 million results in less than a second. It's also something that's defined differently by every company that launches a digital transformation initiative, with as many starting points as there are companies, and usually determined by what can really move the needle at an organization. Case in point, GE Appliances. Back in 2017, the company adopted a new consumer-driven business model that internally focuses on shrinking the distance between GE Appliances and its customers and embedding an entrepreneurial mindset amongst its employees. One measure of the success of the change, GE Appliances has been transformed from an organization that benchmarked its operations against the automotive industry to one that, when it comes to digital transformation, other companies are now benchmarking their progress against GE Appliances. Digital transformation has been part of that shift, and the 3D transformation is an important component. And that's what we're going to talk to Alison about today. So Alison, let's get started. Just give us a little foundation and tell us briefly about your role at GE Appliances.
Yeah, great. Thanks, Bob. So currently I am the Executive Director for Manufacturing Quality. And really what that means is I have business-wide responsibility for all aspects of our quality costs, internally and externally, at all of our manufacturing sites here in the US, as well as our MABE affiliates. And I've been with GE Appliances for over 22 years. I am an engineer by degree, a mechanical engineer from the University of Louisville. And I actually started my career here at GE Appliances as a co-op. And I was able to build a strong foundation in manufacturing through those co-op experiences, as well as one of our leadership programs. And I've also worked on the product design side of our business as a program manager, a design manager in refrigeration and dishwasher. I've contributed to quite a few of our major new product introductions. I even led the redesign of our top freezer refrigerators in Decatur, Alabama during our Mission 1 investment. And I've also had some other roles in product cost, design quality, where I've really focused on delivering to the business quality and cost out goals. And was also the program senior director during our dishwasher investment in our Louisville-based operation. That was an $80 million investment during the COVID-19 pandemic. And hopefully you'll hear in our discussion today this varied background across manufacturing operations, new product introduction, product design have made me very, very passionate about this 3D transformation journey, because I can see how this approach yields amazing benefits for us across so many different areas.
Alison, really interesting, the experiences that you've had here. Give us a sense of what digital transformation means to GE Appliances at an organizational level. I mean, you've had your experiences, the various roles and transformation projects. What does digital transformation mean to GE?
Yeah, it's a great question. And as Bob said, this is one of the hottest terms out there. I think I've joked in the past, if I had $1 for every time you heard digital transformation, be fantastic. So there's so many ways to think about this phrase, but I'll try to break down how we think about it by comparing it to something that we've all experienced. And that was the transition from paper maps if we remember the ones you had to unfold in your car or at home when you were planning a trip, to now we have, Google or Apple Maps. So in that case, and in the company, getting from point A to point B was always the goal. But how we do that today is fundamentally different through that digital transformation. It was a step change in our daily lives, not just a small adjustment or a small shift. And that's really how we see our step change in digital transformation through our use of three-dimensional scanning, model-based enterprise. Really, these are foundational technologies that are giving a step change transformation on how we design and build our products.
Alison, in a minute, Abe's going to take you back and specifically focus on the 3D transformation that you just talked about. But again, I want to put it in a little bit of context. So back in 2017, GE Appliances took a new approach to your business model. Can you explain that so we just have a little understanding about how 3D transformation fits into that?
Oh, yes, absolutely. The business model change that we made in 2017 really did set the backdrop for this transformation to be successful. So we adopted a new consumer-focused operational strategy that are powered by what we call micro enterprises. We love our acronyms around here, MEs. So you may hear me drop into saying MEs for micro enterprises here. But these micro enterprises really operate as independent business units that are grounded and guided by the local markets they serve and their connections to the consumer. So each one really kind of resembles a startup. Our employees are empowered to make their own decisions among other innovators, partners, users of our products. But they're also an important piece of this is being supported by our platform teams. So these are groups like technology, product service, supply chain. And with each micro enterprise being its own entity, they share these platforms. And these platforms are the connectors. And their job is to connect the best methods, the best technologies to the micro enterprise teams to help them grow in their areas. So we strategically want to grow closer to our customers and owners to make sure that we're inventing and creating products that provide real life solutions for them and really create exciting ownership experiences. So that's a little bit about how the micro enterprise and platform structure works together so we can harness these new technologies, these new opportunities to create value.
Alison, you mentioned before the concept of 3D transformation. I'm sure that's relevant to a lot of GE professionals and your supply chain teams. Give our listeners a little bit of what you're doing in terms of what that means, how it works, and why it's important to you and GE.
Yeah, absolutely. I'll start with the last piece of that on why it's so important. This is really about creating products with better quality and a higher level of craftsmanship. That's what we're delivering to our owners. And we can achieve this through our use of digital tools in a way that makes it easier to design, prototype, move to production, and deliver products that will delight our owners. And we really began this journey about 8 years ago with some benchmarking of the automotive industry. And the first tool that we brought in were 3D blue light scanners. It was a great start for us to get into this new technology, but we realized that just pulling this tool in as a standalone wasn't going to give us the benefits that we needed in this quest towards higher quality, higher craftsmanship. So we kept adding on pieces to the story here. So we piloted a transition from 2D dimensioning to full GD&T, and then on to full model-based definition. So what that means for us practically is we have no more 2D drawings. Everything is based on a three-dimensional part model. And we started pulling together small teams of experts in metrology and dimensional control and really empowered them to transition the business and also upskill our workforce and train them on these new tools and these new approaches. And we moved very quickly. Within 3 years, we had entire new product programs, including the dishwasher program that I mentioned I led, that were following this new 3D control system. And we've just continued to grow our capabilities from there. We're now conducting tolerance analyses in 3D instead of 2D tolerance loops. We've got improved reporting of our data, and even our 3D scanning. That first tool we started with has moved from the development space or the innovation space all the way through into production. So really in relatively short order, 8 years or so, we really transitioned from benchmarking others to becoming the benchmark in this space. And I really think this was possible because of our empowerment of people to learn, create these new processes, and really quickly implement that technology.
Alison, that was a great overview of the process. Now, can you apply it to a product line, like how it's being used in the transformation of one of your products?
Yeah, absolutely. I'll do my best to communicate the improvements in quality and craftsmanship here with just words. This is certainly a case where a picture would be worth 1,000 words, but I'll do my best here. Yeah, we really looked at applying this. I'll mention one of our monogram range programs. We were able to take what we learned from that benchmarking and applied the best elements of digital engineering and dimensional control that were developed with our internal team of experts to this new generation of monogram ranges that we were creating. And this was really about improving quality and getting world-class craftsmanship. So what does that mean? This was about eliminating gaps, visible gaps on the product, refining the interfaces so that they looked like what you might see on a luxury car door, really elevating the luxury and the craftsmanship of the appliance. What we've really seen is as these digital processes evolve, the complexity of product, the quality, the craftsmanship that's important, that also elevates. So just like Google Maps transformation for us, these tools have unlocked so much efficiency, productivity, quality gains through all of the tools that we'll talk more about, computer aided machining, 3D scanning, virtual reality, simulations. Without these technologies, we couldn't deliver a product that meets the level of precision and craftsmanship that the consumer is looking for. And I think what's exciting is that by proliferating these tools across all the micro enterprises, we can deliver this precision across all of our brands and all of our products. It's not limited to just our luxury brands. We can deliver this on everything.
Alison, my understanding is that through this process, you've accomplished a digital ecosystem, which is sort of the holy grail for a lot of organizations going through their digital transformation. In your 3D model, there are 8 areas that have significant impact. I want to talk about 4 that impact specifically, and that's digital performance, the digital manufacturing, the quality, and the metrology. Give us a sense of how that works for you and for GE.
Yeah, great. It truly is a little bit of a holy grail to have this ecosystem all pulled together. It's really built around that 3D product model. That's at the center of all of those 8 pieces. We really want to have a digital enterprise that is, using the full potential of digital transformation. It's not just about scanning or just about having model-based definition in our CAD. It's how do we have this entire thread that works together so that we have digital reuse across the groups, traceability, efficiency, and accuracy. So it definitely is a full ecosystem. So jumping into those 4 areas, you mentioned digital performance first. So we use 3D scanning to support all of our product development efforts. So we are able to take prototype parts that were used early in a product development build, scan them, compare it to the CAD of what the engineer thought the part should be, visualize it with a color map. Very simple. Red equals bad or out of spec. Green equals good and in spec. Very visually rich data. And the team leverages these scans at each step in the product development builds so they can diagnose problems, make changes to improve, make new parts, and then iterate again. So this is all work that we did before. Again, getting from point A to point B was always happening, but it used to take us weeks or sometimes even months to go through these iterations. And now we can do it in days or sometimes hours. Huge transformation for us. When you take that out of product and into manufacturing, I'll share a couple of examples. The first is in the area of ergonomics on the factory floor, which for me in quality is actually a very closely related area. If a job or an operation is hard to do physically, that has the potential to translate to the work not being able to be performed to standard and could impact quality. So we have a digital tool that uses artificial intelligence to assess posture, frequency, duration of work with just a video. So we're able to video operators performing work, and it overlays a sort of digital skeleton. It almost looks like a stick figure over the person, and they don't have to wear a special suit or motion capture sensors or anything like that. And it completes a real-time assessment and then concludes with a report that shows the impact on different parts of the body. For example, was the job challenging on the person's wrist, or did they have a shoulder extension, things like that. So by automating this data collection and having the video, our ergonomic teams can assess jobs very quickly, and they can spend more of their time solving the problems instead of just collecting the data around them. The second piece of this in manufacturing is around building out digital twins of our factories. So digital twins is another term that's really popular, and I just want to explain what it means to us. We are really scanning using our mobile 3D scanning systems all areas of our factories. So when we have a digital twin of the factory, a digital representation of the product from that 3D model, the teams can bring those together, the product and the process, to see interactions in a simulation and start making assessments well before they have physical parts. So this allows us to innovate more. We can trial things digitally before we have to build them in steel. We can also prevent rework because we can simulate things early on before we build it. And it improves our decision making because these are often complex interactions, and we're able to provide data to the teams in a very visually rich way with having it in a 3D way that they're able to interpret and take in that information. So if we move that in now to digital quality, it's about bringing our scanning to the factory floor. So again, that scanning technology we are now using to support ongoing production inspection. So we have labs in all of our factories with different types of technologies. These could be robotic scanners, handheld scanners, or ones, again, that we can take to the shop floor to diagnose an issue. So engineers can walk into our labs in production with a problem and have data within 30 minutes. And that's really enabled by the last piece, the digital metrology. So we have digitized our entire metrology process and have converted a large portion of it to 3D. So our CMMs, our coordinate measuring machines, and our scan boxes, they use a common inspection software, so we can get rich 3D data regardless of the technology that was used to measure the part. So we didn't have to go out and retrofit all of our labs. We were able to upgrade equipment we had and just add in the new scanning equipment. So even data that our quality analysts collect, maybe something like, say, a coating on a dishwasher rack that you can't really use on a scanner or a CMM, they can measure that by hand, but they can still upload that into the same software set. So what's powerful about this is there's a one-stop shop for any and all measurement data. And it's stored for the parts through their entire development cycle, from those early prototypes I first talked about, all the way through into production. And so this has been a huge benefit for us to have these 4 elements, especially for my team on the quality side. It's just been a huge development for us to really rally around that ecosystem and have it all connected together.
Alison, digital implies automation. As we all know, the fear of automation, particularly today when people are talking about digital transformation, AI and ML, is the elimination of people. You used a phrase earlier about how you're democratizing data and upskilling your people. So can you talk a little bit about how that transformation is improving, the job of the people you're working with and upskilling them for the future?
Really, the reason that we're democratizing this data is so we can get information to the people that can solve the problem. And I would say that the people that are closest to the work have the best chance to solve the problem. So I'll highlight how we're doing this with just a couple of examples. So, first, we were having some challenges with one of our large injection molding machines. So, think this is a very large press, something that's big enough to make like a dishwasher tub, very, very large piece of equipment. The team was able to use one of the mobile scanners to capture the entire machine in 3D as well as the surrounding plant environment. And in short order, they were able to see that one component of the machine was out of level, and that was causing the operational issues. So the team that knew the equipment understood what that data was telling them, were able to formulate a plan and quickly correct the machine, make the fix, rescan it to validate the fix, and get that press back into top performance mode. Prior to using the tools, those process experts may have created a fishbone diagram of possible issues and maybe worked through them kind of one at a time through trial and error, or potentially based on prior experience of what worked for them before. But having this data to them, the people that could best solve the problem, able to resolve it much more quickly. The second example is how we leverage that common inspection software in the day-to-day operations in our factories. So we use that data to generate trend charts, statistical process control SPC charts. And those are available on our computers and also on mobile devices. So having trend charts may not be new or different to some teams, but what has been game changing for us is moving that visibility to the factory floor. So we have screens in the factory with what we call a bingo board. So if you imagine there's a little small block for each key measurement of a part or a process, and they're aligned in columns and rows, kind of like a bingo card, which is where bingo board comes for us. And they are color coded red, yellow, green, so that a quality engineer, a machine operator can very quickly see if their process is running to standard or if there may be a new problem that's popped up or an emerging issue. So they can click on that tile and pull up the full 3D scan of the part in question, get that visually rich color map, that red-green color map I talked about earlier, to give them better information on what could cause the problem. So let me give a little example on that. Let's say we have a dishwasher rack. Again, I used that part earlier. And let's say the front to back dimension, how big the rack is running high on the right-hand side of the rack. It's out of specification. In the past, you may have only had that single data point, or maybe even just a measurement from a hand gauge. And then a quality engineer or someone else would have to come in, start expanding the measurement plan, checking more parts, checking more dimensions in the hopes of figuring out what was causing the problem. But now the team, both the quality engineer and the machine operator, can see that that characteristic is starting to trend yellow before it goes out. They can select it, pull up that full 3D scan, and see that the part looks like maybe it's being formed in a trapezoid shape, a little more than a rectangle. They can then go into the process, find the root cause that's creating that condition, and correct it. What's so powerful about this is, in my experience, people love solving problems. They want to come in and make things better. And so giving them tools that expedite their efforts to get to root cause and a way to validate their corrective actions, it's something that's very well received and very quickly adopted by the teams. Once you see the power of these tools and then use them to solve a problem, you're 100% committed to these tools going forward.
Alison, fantastic. Looking back on your experiences, what are your major takeaways? And is there anything different that you would have done other than probably starting sooner?
Yeah, great question. It's been quite a journey for us. And so I'd say I've got probably 5 big takeaways specific to this, and some of them could be applied in other areas as well. Number one is for this transformation, or really any transformation you're undertaking, the key is to just start. Don't stay paralyzed. You have to be okay with knowing you won't have it all figured out at the beginning, and don't let fear of not being able to do everything keep you from doing anything. Go ahead and take the leap. For us, it was purchasing that first 3D scanning system. We didn't have it all figured out, but we took the leap and made that first step. Tied into that is kind of my second one. Give people the space to try and to learn. For us, this wasn't about being able to show the return on investment for that first scanning system. We really just allowed those with a passion for this work to kind of just do it and go purchase that first system so the team could learn and grow. So give people that space. The third one I talked a little bit about here is kind of show versus tell. We could talk and talk and talk about the importance of these approaches, but getting people to use the tools and solve problems made them true believers, and then they became advocates to others as well. So find those opportunities to show versus just telling. The fourth one we did talk about, democratizing data. That I'm very passionate in this space. I know that giving broad access to data will grow the problem-solving capability of your organization. And I don't know about everyone else, but we're always looking to grow that skill set. Manufacturing is never short on problems, and so we need lots of problem solvers. Giving people access to data that will help them really empowers them to build that problem-solving muscle. And then finally, 3D transformation creates better work. This is really cool stuff. Very few people want to come to work every day and use a pencil and graph paper anymore. So utilizing 3D scanners, inspection software, motion capture video, and more, it's a much more stimulating set of tools. And we're passionate about upskilling our talent in this space.
Alison, thank you for that. Hey, before you wrap it up, I just want to take a minute to remind listeners who are about to undertake a digital transformation that this is hard work and it takes new skills. So if you're looking to improve your skills, you might want to check out ASCM CTSC certification. It's designed to equip current and future leaders like Alison with the skills to manage an end-to-end transformation.
Digital transformation has taken on a critical importance and impact. Not surprisingly, it's also the top trend in our latest research. The new certification, as Bob shared, is based on the updated digital score standard, as well as the new digital capabilities model that we just recently published. The CTSC really does enable team members to demonstrate their expertise in not only in supply chain strategy, but provides them an opportunity to lead a major transformation or participate in a major transformation project. As Alison is pointing out, this really does separate organizations going through these digital transformation projects. As indicated here, you need to start, but you need to have competent, capable individuals that understand the organization and the transformation project. We're pretty excited about it. I think it will enable a lot of organizations to really see the benefits of digital transformation, as GE has. So finally, that is all the time that we have today. And thanks, Bob. And thank you, Alison, our guest from GE Appliances. More importantly, thank you for joining us today. We hope you'll be back for our next episode. For The Rebound, I'm Abe Eshkenazi.
And I'm Bob Trebilcock.
All the best, everyone. Thanks.
The Rebound is a joint production of the Association for Supply Chain Management and Supply Chain Management Review. For more information, be sure to visit ascm.org and scmr.com. We hope you'll join us again.